So to sum up what we did yesterday, for this section, which is 8-4, equations as functions. First thing we're going to do is we are going to solve for y equals 3x plus 4. And in order to do that, the same way that you did for your homework last night, we have our x values, we have our function, and we have our y. Now, they don't give us a domain, so that means that we're going to choose a domain. And I want to use the smallest numbers possible that I can, -1, 0, and 1. 3 should suffice. Come on, what are you doing? Thank you. So I just do a -1. That means I'm substituting -1 in where the x is. So this be, oops. So I have 3 multiplied by -1 plus 4. That's going to be 1. Looks familiar from last night, right? Seven. Okay. So now I have my points. Okay. So I'm going to go to -1, 1, -1, 1. 4, 0, 4, perfect. And 1, 7. I'm going to draw my line. What color is this? So there's my line. Looks like my 1, 7 was a little bit off. Now, we already graphed it. We already solved for it. Now we have to decide, is it a function? Let's see what fun stuff I can find here. So I'm going to do my vertical line test. I'm going to get my trusty ruler out and make it look more like a ruler. Oops. Let's put this in the garbage. So here's my vertical line test. I'm going to take my, oops, that's not what I wanted to do. I'm going to take my ruler or my ID and I'm going to move it across here. Now, how do I know if it's not a function? 2 on the same line? Well, there's 2 on the same line. There's one right here and there's one right here, right? Look, it's on a line. There we go. 2 on the same x-axis. That's why I have my line that's vertical. And as long as I only hit any plot points, or as long as the line that we just drew from the plot points doesn't look like this, okay? As long as it doesn't look like that. Because if I went across, it would be hitting right here at the same time that it hits right here. So that would not be a function that way. I did have the one. So here's the vertical line test. It only hits it once. So is it a function?
Yes, it is.
Yes, it is a function. No, because we are going to be dealing with ones that are undefined in situations.
Okay, so why do you use the vertical?
Yeah, that was one of the things that I went back and verified. I was thinking of something else that happens in the future of mathematics. So it's only the vertical line test we're going to be doing. We're not. Right, it's related to something you'll do in the future, and that's why I got thrown off by it. But it's not going that direction, so just the vertical line test. Yeah.
So if you have the 1, 4, that's the function.
So the way, I'll show you ones that are not functions, what they look like. Okay, among some others, what do we do? How can I demonstrate this best? Well, here's some that are not functions. For example, if you have a value of, let's say that this was 3x squared. Okay, let's say if it was 3x squared, and I wanted to do these same amounts, 1 squared is, or negative 1 squared is what? 1. So this would be, let's do this. We have 1 plus 4 is 5. Okay? Then we have 0 squared, so that's just 4. That's still the same. Then we have 3, 1 squared, 3, 7. So we have 1, 7 still, 0, 4 still, but then here, we'll do this. We'll do this. It's going to be more obvious that way. So we have, this one's just going to be 3. This one's just going to be 0. This one's just going to be 3. So we have 1, 3, 0, 0, and 1, 3, I guess, in that situation. Why don't we go here, negative 1. Oh, that's right. Thank you. And what you would have is you would give yourself a parabola, and that's what that will look like when we get to that. Okay? Why is it not a function? This one would be. My fault. This one would be. Darn it. You asked me if it's a function. But it shares no x value, so you're right. I'm wrong. I thought we were asking for a different situation. I got to give those back. Ew. So that reviews from yesterday. I want to get going to what we're doing now. You guys have that written down, right? That 4. Forget the squared. So this one was okay. That's right, thank you. I just want the file to stay accurate. Okay, so I got those 3. Yes, it is a function because it passes the vertical line test. Now we're going to write a definition, which is functional notation. Functional notation. Let's see. It's a bit wordy, but shown as the symbol f of x and it represents the value in the range I'm going to move it up a little bit so you guys in the back can see it better. As a symbol fx and is read f of x and represents a value in the range And that sounds really wordy, but I have full confidence that Debian, oh, so it's just one of those situations. Good, good. So if the function of x, so f of x equals 7x minus 5, I want to make that thicker. And x equals 2. I missed those if-then terms. Now, do you see where x is in that function, f of x, if the function is equal to 7x minus 5? So naturally, if we just said that x equals 2, we're just going to put 2 where those x's are. Or the function f of x when x equals 2, that equals 9. So what we did, for those that may not have caught it, x equals 2, here's your x, here's your x. Okay? Yes, sir? That's, yeah. The word function, to know it's a function. No, it's not times 2. This is not a variable. That's telling you that it's a function.
So the function is 2 equals 9.
No. Well, f of 2. F of 2 for 7x minus 5 is equal to 9.
The function of 2 is 9.
Yes. I like it. Okay, here's another example. If g of x, because this is showing that you can have it be, functions can be represented with different letters. If g of x is equal to 3x plus 4, and okay, no and. Find the following. And did you say 5? I heard someone whisper 5. So here's 3 examples. G to the third. G to the negative 5. And then we have one that's going to go 2. Guidance. 2 GO. That's a 0, sorry. Let's do this first one together. So we have our value of x. So I'm going to rewrite it as being g to the 3 is equal to 3 times 3 plus 4. Three times 3 is 9, plus 4 is 13. Once again, same situation. I have my value for x, so I'm just going to plug that into the same exact one. Negative 15 plus 4 is negative 11. Yes, sir? Oops, thank you. Good catch. Thank you, sir. That would make sense. There. Yes? It is showing you that it is going to be a functional notation. Whenever you see it, it's always going to be italicized, and it's always going to have a value of x inside of a parenthesis. Why isn't it of? Why isn't it just of? So. Oh, I see. I'm showing you that there's multiple ways you can do it. I have an example of why there's two different identifications for functions, because you will have it on your homework tonight, so I made sure that I gave an example of that as well. That's a great question. But it can be any letter. It can be any letter. It can be H, not usually I's, J, K, all that stuff. Yeah, sure. Now with this one here, what's happening to our function? What's different about that one? Yeah. There's a number in front of it. So what's going to happen with this is, since there's a number in front of our function, that means that we have to multiply our function by 2. Since this is how it's going to be there, we have 2 to the 3 zeroed plus 4 is equal to 8. So that's what that function comes out to be. Your answer would be 8. That 2 can hang out there. Don't confuse that for solving for variables, okay? Yes?
I still don't understand what
What represents?
Why does this matter?
The function notation show as the symbol f of x represents the value in the range that corresponds to the value of the domain. So it's allowing you, well, how many variables do we have here? How many variables do we have here? Okay, so that function removes your y value. Okay, do you realize that this, when I say that, I'm saying it's a function, right? Okay. It's allowing us to assign a value for x to come up with our range. They're going to give us domains, and we're going to be able to find the range. So it's very similar to yesterday. Yeah, that's what we're finding. What does this represent? Yeah, it's solving the function. Well, just can we get through these examples where we have multiple ways of doing it? Yeah? Yeah. Okay. Yes. Sorry. Yeah, that one could be a little confusing. Since there's a 2 being multiplied by that function. There. All right. Last example, I believe. Yeah. And I'm also using the same verbiage. So we're given, for a function of x, 3x plus 4. I guess I really liked that one. Find, oops. Find each value. And we have g of 3/4 and f of -3. We have different variables there with different values in the domain. So go ahead and solve these, and I'll show you what I got. Okay, you guys should be done with those by now. And that's what you should have. So if you put the correct value of your domain in the correct function, you would have had those answers, those solutions. Any questions so far? Let's look at your actual homework itself and see if there's anything that pops up.